Hi, boys and girls. Thank you for stopping by my math class today. I'm Mrs. Spencer, and I have a question for you. Who's ready to measure? Today, we will continue using non-standard units to measure and compare length, weight, and volume, and that's SOL 1.10. When we measure, a really important word is length. And length is simply how long, such as you see in the picture. The pencil is being measured by some cubes to determine how long it is, the length. Some words we use when we talk about length and comparing length are shorter, longer, and same as. Another math speak word that's important when we measure is height. And height is simply how tall. Height is very much like length, except that it applies to objects that are vertical. You see in the picture, the boy is standing vertically. So we talk about his height, how tall. And some words we use when we compare height are taller, shorter, or the same as. What can we use to measure? Oh, there are all kinds of things. Can you think of something to use to measure? How about a paperclip? Or a cube? Or maybe even a penny could be used. Whatever we use, we call it a unit. Each of these is 1 unit. A paperclip is 1 unit if we use to measure with it. A cube is 1 unit, and a penny is 1 unit. Let's see how to use one of those units to measure. We're going to measure the length of the bat's wingspan. That's from one tip of his wing to the other. Let's use the paperclip. 1 paperclip, and notice that I'm lining it up with the very beginning of his wing. 2 paperclips or 2 units. And again, notice that I am putting the paperclips end to end. I am touching them without making them overlap or have a big space between them. 3 units, 4 units. And then look at the end. I have a very small space not covered by one of my paper clips. That's okay. We're going to say it's about 4 paper clips long. If I tried to fit another paper clip there, it would be too much. So we're safe in saying our bat's wingspan length is about 4 paper clips long. Let's watch a short video to see some measuring do's and don'ts.
Using paper clips to measure. Can you help me measure my pencil? Here's my problem. I wanted to figure out the length of my pencil using paper clips. I tried to measure correctly, but I kept getting different answers. Let me show you what I did. On my first try, I thought my pencil was 4 paper clips long. Do you see something wrong? On my second try, I thought my pencil was 6 paper clips long. Do you see something wrong here? On my third try, I thought the pencil was 4 paper clips long again. Do you see something I'm doing wrong? On my fourth try, I thought the pencil was 5 paper clips long. Do you see something wrong? Oh, I think I understand. So I have to make sure the paper clips go from the very beginning of the pencil to the very end. I have to put the paper clips in a straight line without overlapping. I have to put the paper clips end to end without leaving any gaps, and I have to use units that are all the same size. Okay, so I started at one end of the pencil and I went to the other. I went in a straight line without overlapping. I didn't leave any gaps in between the paper clips. And I used paper clips that were all the same size this time. I got it! The pencil is 5 paper clips long. Thanks for your help. I wonder if these rules would work for other units, like cubes, or counters, or blocks? What do you think?
Those were some great tips on how to measure. Let's practice that. I'm going to use a paper clip to measure the length of the bird. And notice I'm going to try to put the paper clip even with the bird's beak. I'm using the same length paper clip, the exact same unit like we talked about. Oh, I'm making them touch without overlapping or leaving a space. And I'm trying to line them up from beginning to end. And you can see that there is a little bit of the bird's tail left, but if I put another paper clip there, it wouldn't be close to a whole nother paper clip. So I think it's safe to say that the bird is about 3 paper clips long. Let's measure the length of the pumpkin. I'm going to start at the widest part of the pumpkin with my paper clip. I'm going to start at the very beginning and notice I'm putting them end to end without overlapping or leaving a gap. This time it's a little different than the bird. There is more than half of the paper clip covering the pumpkin. So I'm going to go ahead and round up and say that this pumpkin is about 4 paper clips long. Let's measure the snail. We have to line up our unit as close as possible to the beginning of this snail. And you see that is the snail's little antenna. So I'm going to start the paper clip about there. Line it up end to end without any gaps or overlap. And this time I want you to answer, how long is the snail? Did you say 2 paper clips long? You're exactly right. Great job. Now let's measure the height. Remember, height differs from length because height means vertical. So you can see when we measure the tree, we do it in the same way, except we're measuring the height. We start at the very bottom, and I'm going to line up my paper clips end to end without any gaps or overlap. And we're going to go to the longest part or tallest part of the tree. Yep, I would say that's a pretty good measurement. So I would say that the tree is about 1, 2, 3, 4, 5, 6 paper clips tall. Let's measure the boy in the raincoat. We'll start at the very bottom of his feet. Line up our paper clips end to end. And it almost touches the top, but it wouldn't be a whole nother paper clip. So count up the paper clips and answer, how many paper clips tall is the boy? Did you say 6? Woo woo! Good job. Let's measure how many stars tall the square is. Notice we're switching units. We used paper clips before, but we could use stars. Let's try it in the same way. We're going to start the star at the very bottom of the shape, and we're going to line them up end to end so there are no gaps and no overlaps. So what would we say? our square is about 3 stars
How many
tall.
stars long is the octagon?
Let's try the length of the octagon using stars. What would you say, boys and girls? How many stars long is the octagon? Stop and answer. I hope you said 4. You are exactly right. Let's look at another unit. One of the units we saw in my beginning slide was cubes. We could use cubes to measure length. So let's look at the spoon. Notice the cubes are lined up with the beginning of the spoon and go to the end, and the cubes themselves, since that's what we're using to measure with, are lined up without any gaps, and they are end to end. So let's count. 1, 2, 3, 4, 5, 6, 7. I stopped there because that is where the tip of the spoon is. So we would say it is 7 cubes long. Now you try it. How many cubes long is the apple? Yes, I'm sure you said 2. 1, 2. And the second cube lines up with the end of the apple. Great job. Let's try one more length with cubes. How many cubes long is the crayon? Let's check you. 1, 2, 3, 4, 5. And the last cube lines up with the end of the crayon. So 5 cubes long. Great job. And let's look at a few examples of measuring height with cubes. Remember, height is how tall. So let's look at how tall the computer monitor screen is. 1, 2, 3, 4, 5. The top of the computer screen ends at the 5th cube. So 5 is our correct answer. Now you try it. How tall is the boombox? Yep, I bet you said 3. You would be exactly right. 1, 2, 3. Great job, everybody. Now let's compare length. Remember, at the beginning I told you some words we would use, some math speak, we would use to compare length are shorter, longer, or same as. So let's look at our 2 worms. Worms are pretty cool. Which one is shorter? Which one is longer? Shorter, longer. Let's try it with the pencils. Which one is shorter? Which one is longer? Shorter, longer. Now you think about it. Which lemur has a shorter tail? Which one has a longer tail? Think about that. Point to it on your screen. Which one is shorter? Now, which one is longer? I bet you said this one has a shorter tail and this one has a longer tail. And you're exactly right. Woo woo! Remember, our math speak when we compare height is shorter and taller. So let's look at our trees and figure out which one is shorter. And which one is taller? Yes, good job, boys and girls. You can see this one is not as tall as this one, so we say it is shorter. It's your turn. Which dinosaur is shorter? Dinosaur 1 or dinosaur 2? If you said dinosaur 1 is shorter, you are exactly right. When we put them side by side, we can see that dinosaur 2 is taller. Great job. Let's practice. Which is longer, the insect or the snail? I'll bet you said the snail, and you're exactly right. We can see that the snail is 3 cubes long, while the insect is just 1 cube long. Which is longer, the sandwich or the plate? You're so smart. I'm sure you said the plate. The sandwich is 1, 2, 3, 4, 5, 6 cubes long, and the plate is 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes long. So the plate is longer, of course. Now let's talk about another math speak word when we measure. It's weight. Weight simply means how heavy something is, such as when you go to the doctor and get on the scales. The doctor is measuring your weight. The doctor wants to know how heavy you are. They want to know if you're growing properly as you should. In the picture, you can see that some fruit is being weighed on a scale. There are different kinds of scales we can use, and we're going to look at one of those today. Some words we use when we talk about comparing weight are heavier, lighter, or the same as. When we measure weight, one of the scales we can use is a balance scale. And guess what? You have one in the materials that came with your curriculum for school. So I suggest you go and find it and get it out. And after Mrs. Spencer teaches you how to use it, you can do some cool experiments with weight. One important thing, when you set up your balance scale, you can see that the little blue tip is lined up with this line. It's a little hard to see, but I think you can tell. That means right now the containers are balanced. They are both empty. In fact, right now I'll just show you empty, empty. So what if I put something in my balance scale? Even like one of my cubes. Let's see what's going to happen. Let's let it get back to the middle. Yep, I'm going to put it in the red one. Did you see what happened? The tip is moving a little bit, ever so slightly. Not very much because that cube is very light. It doesn't have a lot of weight, but a little bit, so that it causes the scale to tip. And notice this one is going down because of the weight of the cube. Let's look at how we can tell if an object is heavier or lighter than another one. I have two of my favorite fruits here, an apple and an orange. Which one do you think is heavier? The apple or the orange? Let's find out. To use our balance scale, we can put the apple in one side. Oh, see how it made it go down? That means it's heavier. That weight is pulling it down. But let's put the orange over here. Remember your prediction, apple or orange? Whoa! Did you see how the red bucket went down really fast? And what's in here? The orange. The orange made the red bucket go down further, so it is heavier than the apple. And we would say the apple is lighter than the orange. Let's try weighing two more objects to find out which is heavier and which is lighter. Rubber ducky versus 50 cents, 2 quarters. Which one do you think is heavier? Let's find out. 50 cents in the red bucket. Whoa, that's pretty heavy. Rubber ducky in the yellow bucket. Woo! Woo, if it were a contest for who's heaviest, Rubber Ducky wins. We can say Rubber Ducky is heavier. You saw Rubber Ducky made the yellow bucket go down. The weight of Rubber Ducky is more than the weight of our 2 quarters, or from money, that's 50 cents. I wonder how many quarters it would take to equal Rubber Ducky's weight. One of the math speak words we've talked about today is same as. It's a word, 2 words we use. So let's find out how many quarters it takes to equal 1 Rubber Ducky so that the buckets will be the same as. Make a prediction. How many quarters will be the same weight as Rubber Ducky? Here we go. Rubber Ducky in the yellow, and I have a handful of quarters. Let's count as we put them in. And remember, if it's same as, the tip of the balance scale is going to match up with the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is anything happening? 11, 12, 13. Woo! Success! Rubber Ducky is 13 quarters in weight. 13 quarters is the same as 1 Rubber Ducky. Cool, huh? Let's practice. Decide which is heavy or light. Heavy, light. We have a pencil and a doghouse. Which one is going to be light or lighter, and which is going to be heavier? Lighter, of course. Heavier. Good job. Now I'd like you to try it. Which is light, the insect or the apple? I'm sure you said the insect is light and the apple is heavy. Great job. Let's talk about one more important word when we measure, and that's volume. Volume is simply a measure we use to tell how much is in a container. We can use words like more, less, or same as once again. Remember, volume is a measure of how much is in a container. For example, you see some milk in a measuring cup here. The volume is about 2.5 cups. Or let's look at the volume of this box. It is the amount of toys that are contained in the box. And finally, my favorite, how many pieces of candy? This container will hold about 21 pieces of candy. That's its volume. On my screen, I have 2 containers, a tall, skinny container and a shorter, fat container. And I have a cube. If I were to fill each of these containers with cubes, which one do you think would hold more cubes? Which one would hold less? Or would they hold the same or equal amount? Let's make a prediction. What did you predict? Let's find out. I have a tall, skinny container, and I have a shorter, fat container. I'm going to fill each with cubes, and you're going to help me count, and we're going to see which one holds more. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. About 18 cubes. Let's record that. On my chart, I have the tall, skinny container, 18 cubes. That is the volume of the tall, skinny container. Let's find out how many the short, fat container is going to hold. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's about all it will hold. It's pretty full to the top. So the short, fat container held 10 cubes. Let's record that. So which one has more volume? The tall, skinny container or the short, fat? Of course, ding, 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 ding. Our tall, skinny container holds more, 18 cubes versus 10 cubes. We can measure liquid volume as well. For instance, when we saw the measuring cup with the milk in it, we said it was about 2.5 cups. We had a volume of about 2.5 cups. You probably have seen one of these before. A drink. Sometimes they are 2 liters. That's the volume of that container, how much it will hold. This one happens to be 1 liter. It's one of Mr. Spencer's favorite drinks, sparkling water, and it holds 1 liter. So volume can be liquid or solid. Well, thanks for joining me to explore measurement today, boys and girls. Let's just remember what we've talked about. Length, how long, height, how tall, weight, how heavy, and volume, how much a container will hold. And we measure these in different ways. We can measure length and height with various units, like paper clips, cubes, stars, coins. We can measure weight with our balance scale. We learned all about that. And then volume, of course, we can measure liquid or solid using different items. Thanks for joining me today. I hope you learned a lot about measurement. Practice these things at home. So thanks for joining me today to learn more about measurement and how to measure. Let's review quickly. We learned about length, how long, height, how tall, weight, how heavy, and volume, how much. I hope that you learned some great things about measuring today, and I hope more than just watching Mrs. Spencer, you will go and try to measure some things. Happy measuring!